Hi guys, in this video we're going to look at a type of covalent bonding referred to as dative covalent bonding or coordinate covalent bonding. I will introduce the topic by first speaking of how a covalent bond has been taught to you in terms of how it is formed. We've talked about two nonmetal atoms approaching each other, and each nonmetal atom contributes a single unpaired electron. These two single unpaired electrons will form the bonding pair, which is called the covalent bond. Not all covalently bonded molecules are formed in this way. In a dative or coordinate covalent bond, one atom provides the shared pair of electrons in the covalent bond. That means if we have one atom providing that shared pair of electrons, the other atom must have space in its outer shell to accommodate this pair of electrons. We say that the atom which donates the shared pair of electrons, which we will call a lone pair, is called the donor atom, and the atom which accepts this lone pair of electrons, we call that atom the acceptor atom, or we can even describe it as being electron deficient. So for example, if you look to my screen, you're going to see A with an arrow pointing to B. A is what we call the donor atom. It would possess a lone pair of electrons that it can donate to B, where B has available space in its outer shell to accept this lone pair of electrons, which will become a shared pair, or what we call a bonding pair. We're going to look at all of our examples listed here, and I'm going to start with NH4 plus, and we should be able to, that is, you should be able to draw a molecule which shows dative covalent bonding. We'll start with NH4 plus, where this molecule is formed between ammonia and a proton. We see that nitrogen has a lone pair of electrons, and hydrogen, just being a proton, it would have no electrons in its outer shell. When we draw a molecule which has an overall charge, that is a covalently bonded molecule with an overall charge, we must put square brackets surrounded by, square brackets where the charge is written in the upper right hand corner. So let's draw in our bond. I'm going to draw in the original bonds in the ammonia molecule. And I'm just going to draw my dative covalent bond in a different color, right, as well as the lone pair of electrons to be donated. And you're going to notice I used an arrowhead. We use an arrow to indicate the direction in which the lone pair of electrons will be moving or will be shared. So it shows that ammonia, or nitrogen in this case, is our donor atom and hydrogen is our acceptor atom. Let's try H3o plus. Which is formed between a water molecule and a proton. Right, square brackets, charge in the upper right hand corner. And I'm going to draw my dative covalent bond with an arrow. I'm going to draw in the pair of electrons to be donated in a different color. So I've just redrawn my diagram to show 4 pairs of electrons around that oxygen atom, spaced out as far as possible, right? So this is the hydroxonium ion H3o plus. Let's look at the molecule NH3.BF3, where the dot in the formula of the molecule represents that molecule is bonded via a dative covalent bond. So I'm just going to go ahead and draw the molecule where we have ammonia, it will bond to boron trifluoride, where the nitrogen atom donates its lone pair of electrons to boron trifluoride, which has space in its atomic orbital, that is its outer shell, to accommodate that lone pair of electrons. Last but not least, I'm going to draw Al2Cl6, which is called aluminum chloride, where this Al2Cl6 molecule is formed by 2 AlCl3 molecules. So we're going to join 3 chlorine atoms around our aluminum. So these are our 2 AlCl3 molecules, which will bond to each other at room temperature to give us Al2Cl6. I will keep my diagram very simple by just showing the movement of the lone pair from one chlorine atom to an aluminum atom, such that the molecule that we form is called a dimer. We'll look at this in more detail in a later topic. For now, this is dative or coordinate covalent bonding, where you need to know a definition for this type of bond, as well as be able to draw the molecule which is formed when a dative covalent bond is formed between the respective molecules as seen. So you should be able to draw the ammonium, the hydroxonium ion, the dimer, aluminum chloride, as well as that molecule which is given by the formula NH3.BF3. Before I end off, this formula can also be written as NH3.BF3, where the nitrogen is written next to the dot to show that it is the donor atom and the boron is the acceptor atom.